Today we are going to discuss a scientist's bold predictions about the future, humans establishing themselves in space for possible endings of a colony. This prophecy contains 3 core questions, so let's start with this. How can we establish colonies in space? Is our spacecraft fast enough? Secondly, where is our target planet? Has a suitable human habitat been found? An inhabited planet? Finally, once a colony is established in space, how can we predict our own future? These questions have been studied by physicists, astronomers, and anthropologists separately. Hundreds of years of research. Now, we combine all of these things. Let's discuss this topic together. When discussing space immigration, inevitably, the issue of speed has to be taken into account. The current one has a theoretical basis, and the technology that may be realized in the future is superluminal travel. This engine is capable of quickly transporting humans deep into the universe. Technology. In science fiction, Star Trek, the Enterprise spacecraft can travel 9,000 times the speed of light, speed flight, and in Star Wars, the speed of the Millennium Falcon spacecraft, 9 million times the speed of light. In comparison, the fastest spacecraft currently in existence, the Parker Solar Probe, with the gravitational pull of Venus, it took 7 years, after 24 flybys, to reach 0.006 times the speed of light. At this speed, to reach our nearest star, Proxima Centauri, it will take at least 7,000 years, and if you use the Enterprise, it only takes 4 hours. The Millennium Falcon takes only 14.5 seconds. However, faster-than-light engines and space propulsion sound very science fiction-like, right? Well, Einstein proved that nothing in the universe can travel faster than the speed of light. The speed of light appears to be the ultimate limit constraining humanity. Our robots will never be able to travel faster than light. But is that really the case? Actually, physicists have discovered ways to break this barrier. The possibility of such a system. In 1994, a Mexican scholar claimed to have solved the secret to faster-than-light flight. At that time, he was studying for a doctorate at a university in England. At first, his views were not taken seriously, but 3 months later, his paper was suddenly published. Overnight. This is a Mexican named Alcubierre, only 30 years old, but he really proved with a formula the possibility of faster-than-light travel. Since then, academia has studied the hyperdrive he designed. It's called the Alcubierre engine, and the principle is very simple. It's a little bit like surfing. When you're surfing, you're standing on your board. You're not actually moving. It's the waves that are pushing you forward. So Alcubierre imagined, since Einstein said, spacetime is like a curved wave. Massive objects bend spacetime, and the force generated by that bending is called gravity. Can we take advantage of this bending? What about building a spacetime surfboard? Is that so? The spaceship is relatively still on the spacetime surfboard, and the board itself is propelled at warp speed, pushing the spacecraft to a distant destination in an instant. It's not moving. Make spacetime move. It's like a surfer doesn't move. The board doesn't move. It's the sea itself that's moving. This doesn't violate relativity. In the paper, Alcubierre proved by calculation this kind of spacetime surfboard works. Einstein's general theory of relativity, although it stipulates nothing in spacetime can exceed the speed of light, but spacetime itself is not limited by this. At the same time, scientists also have observed many faster-than-light phenomena as the universe accelerates its expansion far faster than the speed of light. The speed of spacetime distortion in the black hole event horizon is also extremely high. Time travel is like a wave. The hardness of this layer of wave can be calculated out. That's 4 times the speed of light divided by 8 times gravity. In other words, to bend spacetime to make waves, we just need enough gravity. Although this is technically very difficult, but in theory it is possible. Just use Einstein's equations. E equals mc squared, generating mass from energy, and then mass creates gravity. In theory, spacetime surfboards can reach 9,000 times the speed of light. In 2011, a Loki department in NASA suddenly published an article entitled Warp Drive, 101 Papers, written by the renowned NASA scientist Harold White. He directly proposes, I designed a warp structure able to significantly reduce the Alcubierre engine's difficulty. It only takes about 700 kilograms of mass. A spacecraft with a diameter of 10 meters can reach 10 times the speed of light. White's design. The shape of the spacecraft was remodeled into two rings, and Alcubierre's spacetime surfboard is simplified into a bubble surrounding the spacecraft. Spacetime is in a bubble created between these two rings, moving fast. From the inside of the spacecraft, time passes normally. It's like a tunnel being stretched around. Time flows here, and then all of a sudden, you appear in another spacetime, tens of thousands of light years away. This doesn't violate relativity. In faster-than-light flight, you don't get younger because of time dilation. This is different from the plot in Interstellar. In 2013, White developed this theory in the laboratory, conducted preliminary experiments. Experimental data show that if such a spacetime ring could be built, according to the current state of the art, theoretically, it can reach 10% of the speed of light, although this still cannot achieve faster-than-light speed. But 10% of the speed of light is a huge leap. It would take 42 years to reach Proxima Centauri at this speed. But a round trip to Mars only takes 7 hours. And not now. 2 to 3 years. This is exciting news. From Einstein's equations to build the atomic bomb, it took us 40 years. However, it has been since 1994. Since warp drive conforms to general relativity, it's been 30 years. Maybe in another 30 years, we can manufacture spacecraft that travel at 10% of the speed of light. At the same time, our understanding of dark matter is also growing. Dark matter makes up 68% of the total mass of the universe, although it remains a mystery. But we have determined it can be used to stretch spacetime. This is what Alcubierre envisioned, the driving force behind the spacetime surfboard. It seems, and we're getting very close. Therefore, physicists made the first part of their prediction. In the near future, warp engines will be able to lead us to any planet in space. Thanks for listening. Next time we'll talk about Interstellar, several post-colonial outcomes. Friends who like it, remember to like and follow. Thank you.